Hi, welcome to my video demo of my pet monitor using Python, TensorFlow, Lite, and Twilio. So to begin this video, I'm going to go over the hardware, then I'll run through the code, and then I'll run through some demonstrations about how everything works. So to begin, you can see the basic setup, prototype setup here. We have a Raspberry Pi with the 4WD hat, which is a Pi car hat, and primarily I use this because I needed the servo motor, which is right here. You could probably use something else instead, but this is what I have with me at the time. And then here we have the connection of the Pi camera. You can see this is the layout which we will be using. And there's my dog. So the water bowl will be one of the coordinates, and the sleeping, his bed will be another coordinate. And you can see that camera is pointing towards that for the frame. We have a battery pack, which the main purpose of this is to power the hat. And then we have a self-made treat dispenser using the servo. As you can see here, you can see there at the bottom, which is holding closed the latch. So once that servo disengages, basically the latch will open, and I'll run through a demonstration of that. And you can see the inside of where we put the treats there. So this is the prototype setup for the project. We're going to go through the code. So we begin the code with importing packages that we need, which include Twilio, NumPy, PyCamera, and TensorFlow Lite. The one package that is variable is the PyCar 4WD, which is imported because of the servo. As mentioned in the hardware portion, this could potentially be used with a different type of servo, which could be directly inputted without the PyCar 4WD and directly into the Raspberry Pi. So to begin, we set up with Twilio. We use the credentials that are set up with an account. That also includes the Twilio number and the number that you want to text to. After that, we set up the camera parameters, so the camera width and the camera height, as well as the threshold for classification. So basically, based on whatever score that the classifier gives, which acts as a threshold for what objects want to be detected. And then we reset the servo. That basically closes up the treat dispenser. The next part are the functions in relation to the TensorFlow Lite package default. The base model that I used for this project was efficient.lite. So we begin with loading the labels. We use the Cocoa labels. There are basically 3 different labels that I use for this project, and I'll go into that shortly after. The next parts are dealing with the tensors. We set the input tensor as well as get output tensor based on what is received on the frame. Annotate objects, which is basically taking what is seen from the objects or detect objects, which is below here, and setting the boxes relative to the frame where that object is detected. Within detect objects, we take in the tensors from the input, and then as well as the output tensors to get the detection of the object, which is in the form of the box, which is where the object is detected, as well as the classes, which is used with the index to figure out what object is detected from the Cocoa labels, and then the scores, which relate to the threshold parameter from earlier. So if it meets a certain threshold, it actually gets passed through as an object that is detected. Count is basically how many times of a particular class is detected. So after setting those functions, we then set parameters and run through main, which is the main algorithm. So the main thing that we set in terms of locations are the coordinates. So for this project, I was interested in the bed and the water bowl. So you can see x-min, y-max, y-min, y-max. So x-min is the left side of the frame, y-min is the bottom of the frame. You'll see that these are relative to the frame. There is a negative number for y-min because sometimes there is some messiness with what is captured on the frame that it can go slightly negative. So this is more of a fail-safe. After the coordinates of the objects that we're interested in, we set other parameters, which are in relation mostly to time. So the daytime, everything's in seconds. So for a normal eight-hour day, we have 28,800 seconds. And then everything else is a counter for total time elapsed, to the time that the dog spends on the bed, to time that the dog is drinking water, to the total sleeping time. And then the rest of these are Booleans to help keep track of if the dog has done one of these activities. So we go through the main algorithm here. We set the pi camera. Frame rate is basically 2 frames per second, which actually keeps track of the time. So each frame represents half a second. So each loop here in this continuous capture basically accounts for half a second. And you'll see here total time elapsed plus 0.5. So each time we go through this loop for each frame, we add half a second to the total time elapsed. So for each frame that's captured, we go through the detection objects. So the thing that we check, as I mentioned before, 3 categories that the model detects are dog, cat, and teddy bear. The model basically, I've noticed that it either uses one of these 3 categories, which makes sense because they do look similar to the computer vision model. If there are better models, perhaps we could differentiate better between a dog, cat, and teddy bear, but for these purposes, we just check for all 3 because there's only one pet that is in frame at any time. So once one of these 3 categories is detected on the frame, we then check if the pet is detected in which location. So for example, the first check is the water bowl. If the dog has been detected in that location for a certain amount of time, we then send the message that the dog has drank water. If he is not at that location, the water time counter resets, and we check the next thing, which is if the dog is sleeping, and it follows a similar logic. If he's been in the bed for a certain predetermined amount of time, the message sends. And at the same time, the other thing with the sleeping portion is if he leaves the bed after the sleeping thing is set, the sleeping Boolean is set to true, then we get a message that he is done sleeping. So after those checks, the servo treat dispenser is just simply based on total time elapsed. So once that time elapsed, based on the counter relative to the daytime, the servo dispenser gets set at a different angle, which then releases the latch. And then finally, once the total time elapses past the daytime that was set, the summary text is then sent. So that basically is the overall run through of the main algorithm. And the next part will go through a video representation of what actually happens on screen, as well as each portion of what exactly the pet monitor does.
This is what the interface looks like when there is no dog in the frame. So this is what it looks like in real life. So as you can see, he isn't here. The time elapsed is going, as I just printed it out, each incremented by half a second. So now you can see that the dog is detected, and I'm printing out time on screen, which is below time elapsed. So he's in neither location of either the bed or the water bowl. So only the dog on frame is being captured, and that's what is incrementing right now. So now reverting back, the dog is now off the screen. So you can see our counter here, the time elapsed is still going, but the dog on screen has stopped. Now we're demonstrating the dog sleeping. So as you can see, he's lying down on his bed. The increment of the dog sleeping time is going. And as you can see, here he is. So just for testing purposes, I set this at 20 seconds. So that just set it. And then that should send a text, which I should be receiving shortly. And here it is. Leo is sleeping. For this portion, we're going to test as if he were drinking water. So you can see he's off the frame right now. But I'm going to use treats to replicate the water bowl if he were to. So it would be about 1.5 seconds. That's my assumption that I'm making. So we can see here. So if I throw treats there, it moves over there. Water time has gone through. And then as you can see, he has drank water. For this portion, we're testing the servo-based treat dispenser. I just set that at half the day. So this should go, there we go. So that was about 10 seconds. I set the day at 20 seconds. And as you can see, it released over. We're gonna simulate a day of 20 seconds. So you can see he's off the frame right now. But about halfway through, which is about 10 seconds, the servo releases. Now he's captured on the frame, which we'll see in the summary. But he's neither sleeping nor at the water bowl. So you can see here, time on the frame and time off the frame in parts of a minute. He didn't sleep this time, he didn't count water, and the treats were released.